Have you ever wondered how the internet feels so, well, instant? You know, how a video can start playing with zero buffering or a website just appears in the blink of an eye? Well, I'm going to let you in on a little secret. It's not magic. It's actually a really brilliant set of engineering tricks that are basically designed to bend the laws of physics. And today, we're going to pull back the curtain on the internet's secret speed boost.
I mean, seriously, think about this video right now. You clicked play and boom, here I am. There was no loading bar, no waiting. How is that even possible? The server that's holding this video file could be thousands of miles away from you. So how in the world did it get to your screen so fast?
The answer, and this is the fun part, is that the internet is cheating. Yep, it's finding these incredibly clever ways to get around the physical limits of distance and, the actual speed of light. It pulls this off with two super powerful technologies that work together, caching and edge computing. And that's exactly what we're going to break down right now.
All right, so here's our game plan. First, we're going to talk about the big problem, our universal need for speed. Then we'll get into the internet's first big cheat code, caching, using a really simple analogy. We'll meet the superstar of caching, a tool called Redis. After that, we're going to go beyond just data and look at moving our actual computer code to the edge. And finally, we'll see how it all comes together to create the instant internet of the future.
So, let's start with the basic challenge here. No matter what you're doing online, streaming, shopping, anything, speed is everything. Let's be honest, we have absolutely zero patience for waiting. But here's the problem, the bottleneck. The main servers and databases have physical limits. A really complex calculation takes time. Reading data from a hard drive takes time, and just sending that information across the world, that takes time too. That's the battle we're trying to win.
So how do we start to beat that clock? Well, the first big weapon in our arsenal is something called caching. And to really get what it is, we're going to use this perfect analogy that makes it all just click, the librarian's secret.
At its core, caching is a really simple idea. You just figure out what data people are asking for over and over and over again, and you store a copy of it in a temporary, super fast place. That temporary spot, that's your cache. It's so much faster to grab something from the cache than to go all the way back to the main, slower database every single time. It's the ultimate strategic shortcut.
And this librarian analogy just nails it. Okay, imagine your main database is this enormous library with millions of books. The slow way is having that poor librarian run all the way to the back of the library, find a book, and run back every single time someone asks for one. The fast way? Well, the smart librarian notices that everyone keeps asking for the same, say, 10 bestsellers. So what do? They keep a stack of those popular books right there at the front desk. That front desk, that's your cache. It's not the whole library, but for the stuff everybody wants, it's instant.
Now that front desk is the concept, right? But you need an actual front desk. And when it comes to the technology that acts as this high-speed cache for the internet, there is one undisputed king. So let's talk about the caching superstar, Redis.
So the secret to Redis's incredible speed is that it's an in-memory data store. That just means it holds all its information directly in RAM. The super fast memory your computer uses for whatever it's doing right now. We're talking orders of magnitude faster than a traditional disk. It's also a key value store, which is just a fancy way of saying it works like a simple dictionary. You give it a key, like trending movies, and it gives you back the value, which is the list of movies. It's an incredibly simple and fast way to look things up. The trade-off? RAM is temporary. If the power goes out, that data is gone. That's why it's perfect for a cache, not for your permanent data.
Okay, so how does this work in the real world? A perfect example is caching an API response. Think about the trending now list on your favorite streaming app. The slow way to figure that out is a heavy, complex database query. So instead of doing that for every single person who opens the app, the system just does it once, maybe every few minutes, and saves that list in Redis. Now when you open the app, you get that list instantly from the Redis cache. The main database never even gets bothered. It's brilliant.
Another huge one is user session storage. You know when you log into a website and then you click around and it remembers who you are? That's a session. Storing that session info in super fast Redis instead of hitting the main database for every click you make is what makes the whole experience feel so quick and snappy. Redis is also an absolute beast for real-time analytics. Because it can write and update things so incredibly fast, it's perfect for stuff like a live viewer count on a stream. Every time someone joins or leaves, a little counter on Redis gets updated instantly, without putting any stress on the main database.
And finally, a really important security one, rate limiting. To stop bots from spamming your site, you can use Redis to count how many times a user has made a request in, say, the last minute. If they go over the limit, you can block them. Of course, the real trick for engineers isn't just setting the cache. It's knowing when to clear it out so people don't see old information. But for a simple counter like this, Redis is just perfect.
Okay, so caching with Redis is a total game changer for speeding up data. But what if we could take this whole idea a step further? What if instead of just moving the data closer to people, we could move the actual computer code, the decision-making logic, closer to them too? This brings us to the next massive idea, the edge.
So this is a really crucial difference to understand. A lot of you have probably heard of a CDN, a content delivery network. They're amazing. They take static files, like this video, or images on a website, and they copy them to servers all over the world so they're physically closer to you. Edge computing is the next giant leap. It lets us run our actual code, our logic, our decision-making on that same global network.
And honestly, this is the perfect way to think about it. Imagine your main server is corporate headquarters. An edge function is like giving your local branch manager the power to make common-sense decisions on their own. They don't need to phone up HQ for every little thing. It's way faster, it's more efficient, and it lets headquarters focus on the really big stuff.
So, what kind of decisions can this local branch manager actually make? Let's look at some really powerful, real-world examples of running code on the edge.
Now, when we talk about this technology, you're going to hear two names come up constantly: AWS Lambda Edge and Cloudflare Workers. These are platforms from the big cloud companies that let developers write these little chunks of code and just deploy them instantly to the entire global network. A big focus for them is making sure the code runs fast every time, minimizing what's called a cold start.
All right, let's think about a real security problem. A user tries to get to a page they shouldn't have access to, maybe using an old, expired login token. What is the absolute fastest and most efficient way to block that bad request?
This is where the edge is just so smart. The user's request doesn't go all the way to your main server. No, it hits the closest edge server first. An edge function running there takes one look at the token, sees it's invalid, and rejects the request right there on the spot. That bad request is stopped cold before it ever gets a chance to waste even a millisecond of your main server's time. It's a faster, stronger front line of defense.
And the list of these edge superpowers just goes on. You can do A/B testing, deciding whether to show a user a new feature right at the edge with basically zero delay. You can do image optimization on the fly, resizing a picture perfectly for a phone or a desktop. And for massive live streams, the edge can build personalized video playlists for every single viewer, taking a huge load off the central servers.
Okay, so let's pull all of this together. We've used caching to bring our most popular data closer to the user, and we've used edge computing to bring our code, our logic, closer to them too. So what does this all mean for the future of the internet?
Here's the key takeaway, the bottom line. When you combine a powerful cache like Redis with the global intelligence of edge computing, you are building a fundamentally better internet. It's not just about being faster. It's an internet that's smarter, more personalized, and way more resilient. It's how we deliver those truly instant experiences that, let's face it, we all expect now.
And this all leaves us with one last, really fascinating question to think about. As we keep pushing more and more of this intelligence out to the edge, as we make those local branches smarter and more powerful, what happens to corporate headquarters? What is the role of the main central server going to be in the future? It's a huge shift in thinking, and it's going to define how we build the next generation of applications. Thanks for watching.